Hello and welcome everyone. My name is Poeschko. I work on the Wolfram Cloud team. And today I want to talk about the history, current development, and the future of Mathematica Online. There is some overlap of this talk with a talk I gave previously about what's new in the cloud in general. But in this talk, I want to focus a little more on the history and the technical challenges involved in implementing notebooks on the web. Yeah, let's dive right into the history of this project. It started around August 2010, so pretty much 10 years ago. At the beginning, it was very simple. Obviously, there was a very simple cell editor that didn't have any particular features. It was just a plain text editor, and there was basically bitmap output coming straight from Web Mathematica, which this project kind of originated from. A bit after that, there was some interface around that, at least, so you could manage your files in the cloud, and it started to look like a notebook in a sense, but it was all still very, very simplistic. What happened then over time is that we implemented a more powerful editor. So we added things like syntax highlighting, auto completions, and many other useful editor features. The notebook rendering mechanism became more powerful. So instead of just relying on bitmaps coming straight from the server, we started to implement the full box rendering mechanism in JavaScript to have that run in the browser. And a particularly important use case was to support manipulate. It would have been possible to some extent to kind of have a custom implementation of manipulate in JavaScript with all its controls and various aspects. But it turned out that it was just too complicated to replicate all of the stuff that we already had in Wolfram language to port that to JavaScript. So what we'd rather do is implement box rendering in JavaScript. So we can use the same Wolfram language code that implements manipulate. It's just that at the very end, we render the boxes that it generates. And the same was true for the suggestions bar, for instance, that also started at the very beginning as a custom JavaScript implementation, but in the end, we moved to just rendering the boxes that are already implemented by Wolfram language functions. Graphics obviously are very important in notebooks as well. So after we had just the plain bitmap output, what we started to do was render vector graphics based on JSON data. That was still coming from the server, but it allowed for more interactivity and also nicer rendering as SVG graphics. Another important aspect of the cloud became managing your files in the cloud. And we introduced this concept of cloud objects in the Wolfram language that allow you to operate with the cloud pretty much like you would with a local file system, and move files there, deploy notebooks, change permissions, and all these things. There's also a lot of stuff that changed under the hood over time. So at the very beginning, it was a big pile of jQuery JavaScript code. After a while, it became pretty unmanageable. And so we started to move towards React.js to implement things in the browser. The nice thing there was that it allowed for pretty incremental adoption. So we started to use React.js for cells and boxes first in the notebook world. And then ultimately, we moved to React for the whole user interface, so also for the stuff around the notebook. And basically just this year, we completed that process of moving everything to a nice React-based implementation. We also started to introduce a custom JavaScript framework to manage the lifecycle and the state of cells and boxes. Turned out that neither React.js nor any other existing framework did quite what we wanted in that area, just because notebook rendering is pretty special and challenging. At some point, we might even open source that framework as well in case it's useful to others. And another perhaps interesting thing that developed over time is a whole expression representation and also client-side evaluator that can take Wolfram language expressions and evaluate them purely on the client side in JavaScript code to, for instance, allow for quick resolution of certain dynamics in the notebook. So as you can see here, our code base certainly grew over time as expected, particularly the JavaScript portion. At some point, it overtook the Java side. And yeah, there's also some CSS, obviously, and there's also some Wolfram language code that we wrote specifically for the cloud. It's actually, what you see in this diagram is just the main repository. There's actually more stuff that's not reflected here, especially in terms of Wolfram language code. And of course, this doesn't even take into account any of the kernel code that's still running under the hood in the cloud, of course. So you might be wondering, what's so challenging actually? Why is it so hard to implement all of this in the browser? And just to illustrate that a little bit, let's look at an example like this grid with 2 items. What you can see here is that in a notebook, what we want to do is line wrap things so that both items fit into the notebook according to the current notebook width. And we also introduce digit groups and separators between them to make the numbers more readable. If you compare that to what the browser would do by default, in the built-in HTML rendering, if you just export that same grid to raw HTML, what we get is something like this. So it just looks completely different. There's no digit groups, there's no line wrapping to make everything fit on the screen. And it would certainly be possible to improve that somewhat, but to get the exact same rendering that we need in notebooks, we just need to go a level deeper, and we can't just only rely on HTML and CSS, but we need to actually tell the browser where to put everything on the screen. So we're really implementing our own layout engine in the cloud, in our JavaScript front end. So if you look at the browser DOM that's under the hood here, you'll see that there is a bunch of HTML nodes that are each positioned absolutely exactly where we want them to be, as opposed to a single node that contains the whole number in this case. That's at least in cases like this where we have to do that. Whenever there's a long piece of text that would work just fine in the browser and its native rendering, then we rely on that, of course. And it doesn't stop with grids, of course. What we need to support in notebooks is the whole typesetting and its rendering. So if you have some a little more complicated math like here, we need to render things like fractions and square roots and make sure that all works nicely. By the way, this is, of course, running in a web browser right now. So it's a notebook on wolframcloud.com that just happens to be in slideshow mode. And I could also go and resize that just to highlight that this is all responsive and rendered on the fly on the client side. It's not like it's just a bitmap that's coming from the server. And yeah, maybe you might also be wondering, why don't we just use some existing library to render all this math output? Because there certainly exist libraries that do that. But it gets even trickier than that, because in the Wolfram language and Wolfram notebooks, you can nest things pretty much arbitrarily. So like here, I have this math output, but I could go and, it's a little contrived, but I can do that in the language. I can replace the symbol X with a button that does stuff. And now I want to be able to click that to print something. And this is the sort of thing that just no existing library would provide for us to be able to nest things arbitrarily and not just have math output that's sort of standalone. One particularly challenging thing are growable characters. You can already see them here to some extent, like these parentheses, they grow as necessary. But to illustrate that further on the square root sign, so you can see that the square root sign adapts according to the size of the contents, as it should. And that's one of the things that a browser wouldn't just do for you. And basically what we do here is we have a bunch of JavaScript code that takes glyphs from the font, deconstructs them into their paths, and then reassembles them as necessary to construct a sign like this. That's how we render things in JavaScript. There is a big open project that's still on our to-do list that we're slowly working towards, and that's a full typesetting editor. So what works right now is typesetting in output, in basically read-only cells, but they're not editable as such. So right now you can't place a selection inside a fraction in a Cloud notebook and edit that, even if it renders just fine. But there are a couple of ways to work around that I wanted to show you. And one of them is input form-based input. So let's say you type in some code and then you want to insert a fraction. We don't support control / and the various things that work on desktop, but you can press Control-Shift-1, which brings up this little input box. It looks a little distorted here in slideshow mode, so I hope you can see it somewhat. What I can type here now is x/y. Let's do x/y squared. So typing this in, as the name says, input form, and then I press enter, and then it typesets. So this is a way to get typesetting constructs, even though you can't edit them directly in the cloud. And now I can, if I want to make a change, I can just click this again and resolve it again. And of course, this is fully semantically meaningful. So, I can do things like this, some computation around it, and it will do the right thing. So that's one way to enter more complicated typesetting constructs. What's also coming soon is a similar thing, just based on text syntax. So instead of input form, you can type text syntax, which might be already familiar for a couple of people. And this works sort of as an inline control inside of cells. There's a similar thing that works on the whole cell level. So if I just start typing here, I can then select the cell and press Control-Shift-N on Mac, and it will convert the whole cell from input form to standard form. You can go back with Control-Shift-I in this case. There's also evaluate in place, similarly to desktop Mathematica. So I could select a part of an expression in a Cloud notebook, press Command-Enter on Mac, and it will evaluate the thing and replace whatever selection I had with the result of the evaluation. It can also be useful to work around the typesetting editor limitations in the cloud sometime. And again, of course, this has the right semantic meaning. So if I evaluate this, it does the right thing. Similarly, there's also a way to take output and reuse it elsewhere. It's just a little different from desktop. So if I evaluate this, unfortunately, I can't place a granular selection here because that's something that the browser just wouldn't support natively. So that's what we also need a full typesetting editor in the end for. But what you can do is you can copy the whole thing. And we made that particularly convenient by adding click to copy. So you can just hover over this cell, copy it, and then the thing is on the clipboard, and you can now, start typing a new cell and paste that. So yeah, these were a few ways you can work around some of the limitations that currently still exist in Cloud notebooks in terms of typesetting in the editor. Now I want to talk a little bit about the things we were just working on over the last year or so and what our current focus is in terms of development. One thing that's currently in our focus is graphics rendering and improving the performance and also the interactivity of that. What we're doing is basically implementing the whole graphics rendering pipeline in JavaScript as well. so far, for most graphics, we still rely on data that's generated on the server and then translated into SVG graphics on the client. But increasingly, we're supporting more and more graphics primitives and directives, and we can render them directly in the browser based on the graphics box expression. What that allows us to do in combination with our client-side evaluator of expressions is, things like this pretty dynamic animation of the planets in this case that runs purely on the client side, even though it's fully implemented in Wolfram language. So it's quite a bit of code, so I won't go into the details, but it's basically just constructing graphics on the fly in an animator. Yeah, that's the whole project to implement graphics, and that comes with supporting dynamics inside graphics at a much better level. Another thing we're working on is what we call interactive graphics. And the idea here is that for certain plots and perhaps other graphics, we add various interactive effects to make them nicer to look at and nicer to work with. So for a plot like this, we might add highlights of the nearest point and also add drop lines so you can see on the axis where you're at right now. And this is sort of a combination of things that happen in the kernel when the graphic is generated and corresponding mechanisms that take various annotations produced by the kernel and turn them into interactive effects like this. So some of this is hopefully coming in 12.2, and then there's certainly more coming later, at some point also allowing you as a user to have low-level control over what's going on in terms of these interactive effects. Beyond graphics, we're also constantly working on notebook performance, particularly loading speed. One thing that's been crucial for a while is that we render notebooks on the server side and generate static HTML that can be used to display something on the client side right away as you load a notebook. So that's sort of a trade-off in terms of making things more interactive and supporting more box rendering in our JavaScript front end, is that it also needs that JavaScript to render stuff, obviously. If you have to wait for that rendering to happen on the client side before you could see anything, that will be a bit slow. So that's why we also execute that same JavaScript code on the server side to produce static HTML. Yeah, one thing that we've worked on recently in this area is a completely static initial rendering mode of notebooks that allows the notebook to finish loading even faster. If we take a look at an example how it would look before, this is actually even without an HTML cache. So what happens is that it loads the notebook, it has to download a bunch of JavaScript code, and then it starts rendering cells in this notebook, and it's rather slow. So it's a bit frustrating to open this notebook in the cloud because it takes such a long time for this little blue progress bar to finish and for the whole notebook to become available. But with this new mechanism that we've implemented, it basically looks like this. So this is running a branch that's not merged yet, but it's coming soon in 157, and then you can see that the whole progress is much faster. And I can already scroll through the notebook, it's all there, and it might take a little while for the browser to update things as I scroll through the notebook, but it's still a very smooth experience. So even if you have a fairly large notebook, it's safe to publish it to the cloud, and it will render so just fine and in a reasonable time as you open it. The way we achieve that is by not making every cell interactive right away. So particularly we avoid a bunch of kernel evaluations to update various dynamic content if you just open the notebook. But that's not a huge downside because we can actually make things interactive on demand. So here I have a notebook that I also put into this static rendering mode. And now when I start interacting with it, so I start dragging the slider here, it will actually render the cell on demand, make it interactive, and I can just keep interacting with it and move that slider around. And this works not only for sliders and manipulate, but also for buttons. So I can just click this, it becomes interactive, or select graphics and resize them. So that all just works basically without having this big overhead of rendering everything interactively right away as you open the notebook. That's the idea of this static rendering mode. What we'll probably do is enable this by default for large notebooks beyond a certain file size, and if they contain a certain number of cells. But you can also control this through a Cloud Object option called Cloud Rendering Method. So these are a few of the things we're currently working on in terms of notebooks in the cloud, but also wanted to give you a quick introduction to working with cloud objects in the cloud, because that's something that you might not usually see if you just work with notebooks. So the fundamental principle is that every file, every notebook in the cloud is a cloud object and has a corresponding handle, so to say. And you can actually see that by evaluating the evaluation cloud object. In this case, it's this URL here. And then, once you have a cloud object, you can do various things with it, like changing its permissions. In this case, I could make this public or anyone read by using set permissions. I can also publish something new to the cloud using cloud publish and then give an expression, in this case, a manipulate, and also a name where I want to publish it to. To execute this, I get back a cloud object at the specified place. And then if I open this, it's just this manipulate that anybody could look at. And this, by the way, works both from within a cloud notebook and from desktop Mathematica if you have it running locally. There's a whole bunch of other functions to manage content in the cloud, and a guide page in the documentation that lists all of them. So take a look here if you want to find more functions. One thing that I wanted to mention in particular is the different views or URL types of cloud objects, because it might not be obvious, and it's certainly something that we also need to still document better. But the idea is that for each object, there is different views, and most importantly, there's the environment view and the object view. In the environment view, the idea is that you can edit things, and it's using your session kernel that's sort of tied to your account. That also means that you can only get to this view if you're authenticated, if you have a Wolfram Cloud account, which means that it's not typically the kind of URL you want to hand out to other people if they're not using the cloud or Mathematica Online themselves. If you just want to share something with the world, with anyone else who might not have a Wolfram Cloud account, you usually want to use the object view. And that's what you usually see in cloud object URLs by default. There's no restriction to who can get to the object view as long as they have the corresponding permissions. But the only thing you can do in that view is read and interact. You can't edit stuff, and you can't evaluate whole cells. Part of the reasons for that is that this uses a different kind of kernel, which might also consume cloud credits if you go beyond a certain limit and you enable that. Right now, we can see that we're in the environment view, denoted by this env in the URL, but I could easily change the URL type of a cloud object by either specifying cloud object URL type goes to object, or comparison environment, then I get a different one. One URL type we added recently is a download. So if you want to hand out the URL and allow somebody else to quickly download the file, this is the sort of thing you want. As soon as I click this, it triggers a download of the notebook file to my local file system. So yeah, that was a quick introduction to cloud objects and what you can do with them. Just a few more things, what's on our roadmap for the future. Certainly, we'll keep working on performance improvements and improving robustness of the cloud overall. There's, for instance, one idea to use the Wolfram language compiler to generate WebAssembly so that certain pieces of Wolfram language code can run purely on the client side without needing a kernel on the server. We're also starting to make a big effort towards better accessibility. For instance, making sure that cloud notebooks work well with screen readers. As we already saw, there's still some limitation in terms of the typesetting editor, but that's certainly something we want to implement fully in the future. And another more technical thing under the hood that we're starting to work on is to move the cloud to containers and Kubernetes. That was a quick introduction to the cloud, to its history and some of the challenges that we're facing, some of the things we're currently working on. If you want to learn more about what's going into each release, please take a look at our release notes that we publish for each release. I'm also happy that we finally have a list of supported and unsupported Wolfram language functions in the cloud. So if you ever wonder whether something is supported or not supported yet in the cloud, then take a look at this document. And particularly if you want to know more about cloud notebooks and the things that are going on under the hood, then take a look at these cloud notebooks implementation notes. Please feel free to get in touch via email or reach out on community. And yeah, thank you for listening. I'll address Ita's question first. Does convert to standard form work on less than a whole cell in relationship to shift control 1? I guess it should. I'm not sure if it does right now. We should try that, but I don't see a reason why it shouldn't. So that is basically another way to do a very similar thing. I think the main reason for this other control was to have something that's familiar. It's similar to this upcoming tech input, and also control equals in a sense, and it also makes it a bit more discoverable in the menu. You can go, insert this input form type input. But other than that, the principle is certainly very similar to the whole cell transformation. John, do you really want to talk about collaborative editing? I did just allow you to talk as well. So, I mean, I'd say that the big question is, should we focus on collaborative editing or should we do a typesetting editor first? I mean, they're somewhat related, and some of the groundwork will probably be applicable to both, but then we have to decide which is more important. And I think the reasoning so far has been that we might get collaborative editing, at least in some limited form, through a different mechanism similar to the chat framework, basically, or using the channel framework. So it wouldn't be a full-blown collaborative editor that supports going down to a very granular level and being able to have have multiple people editing the same cell at the same time, for instance. That probably wouldn't work. But some simple form could maybe be made to work with some high level implementation, while sort of the core the focus of the core notebook work would be on the typesetting editor. That was one of our considerations. So depends a bit. That channel and chat framework thing, that also depends on service links. So that's a low-level thing we'll need in the cloud first. But once we have that, then there is a good chance it could just work, basically. But yeah, the implementing the full editor with live collaboration, that would be a longer-term project.
So I asked my question in the chat. And so maybe you answered it while I was fighting with browsers. But does convert? Okay.
Yeah. But and I think it's really just the four of us, so we can just talk about it again. I see Itai, John, Andrea, Matthew. I assume nobody else is here and has any questions. So then we might as well talk about that again. Yeah, it's certainly very similar. I don't see a reason why convert to standard form shouldn't work for parts of a cell. So if it doesn't, then we should make that work. I think there's still some reason why we might want this shift control 1 input, since it's just more discoverable in the menu, and it's just similar to the tech-based input as well.
I see. Yeah, it seems. I mean, if you have really convert to standard form and convert to input form, this seems kind of redundant.
Yeah, to some extent it might be. I think it's really mostly about discoverability and yeah, something a little more familiar maybe. Does it work on desktop to convert parts of a cell?
Yes, absolutely.
Okay.
I mean, it has to be a full expression, right? You can't convert part of an expression. Mm-hmm. But as long as you select, and I suppose that is sort of the advantage of that might be a slight advantage of the shift control 1, that you always know what part is being converted, which I guess you would, because you'd need to select it first before you did shift control N anyway. But then there's no sort of I accidentally selected 1 comma too much or something like that, right? Mm-hmm. And because you've typed right in. So if you've typed something extra, it's your fault for typing it in rather than, bad UI. But yeah, it just, I mean, like the tech thing, there's sort of, I think, value added just because really there isn't. It's right. It's this little foreign thing, but the shift control 1 thing just seems, I guess it rubs me the wrong way.
Got it. Yeah. It's true. Yeah, it's more redundant than the tech thing.
Yeah.
And I just tried it in the cloud. It does not work right now. It seems. I mean, I can press Control Shift N without selecting the whole cell, but then it still applies to the whole cell, it seems.
Okay.
So that's something we should look into.
Okay, cool. Well, nice talk. I'm gonna go grab some lunch before the UI, the front end meetup. If you wanna, don't know if you'll go hang out there too.
Of course. Yep, that's on my list.
Yep.
Okay. And I think, thanks, Ita. Bye. I think we can wrap up here as well, right? Okay.
Great.
Well, thank you. Bye-bye.
Mm-hmm. Bye.